Time is the silent conductor of our lives. It orchestrates our days, weeks, and years. From the moment we wake up to the time we fall asleep, we are governed by its relentless rhythm. But what exactly is time? How do we define something so fundamental, yet so intangible? These are questions that have puzzled humanity for centuries. Join me as we embark on a captivating journey through the realms of science and philosophy to unravel the enigmatic nature of time. In its simplest form, time is a measure of change. It is an ever-present force that governs the rhythm of our lives, from the ticking of a clock to the changing of seasons. It is the yardstick by which we gauge the order and duration of events. Time allows us to sequence our experiences, to understand what came before and what might come after. We mark time in seconds, minutes, and hours. These increments help us organize our daily activities, from waking up in the morning to going to bed at night. These units are arbitrary, but they provide us with a framework to navigate the flow of existence. Without them, our lives would be a chaotic jumble of events with no clear structure. However, time is not merely a human construct. It is a fundamental aspect of the universe itself, influencing everything from the motion of planets to the life cycle of stars. It is woven into the very fabric of the universe. The concept of time is integral to the laws of physics, shaping the way we understand the cosmos. Different cultures have perceived time in diverse ways. Some cultures view time as a linear progression, a straight path from the past through the present to the future. Some view it as linear, while others see it as cyclical. In many Eastern philosophies, time is seen as a repeating cycle, with events recurring in a continuous loop. Ancient civilizations often linked time to celestial movements, observing the cycles of the sun, moon, and stars. These observations were crucial for agricultural planning and religious rituals. These observations gave rise to calendars and the measurement of time. From the ancient sundials to modern atomic clocks, humanity has always sought to understand and measure the passage of time. Sir Isaac Newton, the father of classical physics, envisioned time as an absolute entity. In his universe, time flowed at a constant rate, unaffected by the motion of objects or observers. Imagine a universal clock ticking away, keeping perfect time throughout the cosmos. This Newtonian perspective prevailed for centuries. Newton's laws of motion and gravity provided a remarkably accurate description of the physical world, from the falling of apples to the orbits of planets. Time, in this framework, was a constant, an unwavering backdrop against which the drama of the universe unfolded. In the early 20th century, Albert Einstein shattered our Newtonian conception of time with his groundbreaking theory of relativity. Einstein revealed that time is not absolute but relative. It is intricately intertwined with space, forming a four-dimensional fabric known as space-time. According to Einstein, the flow of time is affected by gravity and motion. Time slows down in stronger gravitational fields and for objects moving at high speeds. This mind-bending concept, known as time dilation, has been experimentally verified. Section 5. Quantum quandaries. Time in the subatomic realm. Delving deeper into the microscopic realm of atoms and particles, quantum physics introduces even more bizarre aspects of time. In this strange and fascinating world, the conventional understanding of time begins to blur and twist, revealing a reality that is both perplexing and intriguing. In the quantum world, events unfold with a certain degree of randomness. Unlike the predictable nature of classical physics, quantum mechanics operates on probabilities, where the outcome of an event can never be determined with absolute certainty. The precise behavior of particles cannot be predicted with absolute certainty. This inherent unpredictability is a fundamental aspect of quantum mechanics, challenging our traditional notions of cause and effect. Quantum entanglement, a phenomenon where two particles become linked and share the same fate, further challenges our understanding of time. When particles become entangled, their properties become intertwined, no matter how far apart they are. If two entangled particles are separated by vast distances, a measurement performed on one instantaneously affects the state of the other, seemingly violating the limitations of time and space. This instantaneous connection suggests that our conventional understanding of time and space may be incomplete, opening up new possibilities for how we perceive the universe. Section 6. Time through the philosophical lens. Reality or illusion? Philosophers have grappled with the nature of time for centuries, pondering its reality and our perception of it. Is time an objective feature of the universe, or is it merely a construct of the human mind? The A theory of time posits that there is a fundamental distinction between past, present, and future. The present moment holds a unique significance. In contrast, the B theory argues that all moments in time are equally real, and our perception of a flowing present is an illusion. Section 7. The mind's clock, our subjective time experience. Our psychological perception of time can be fluid and subjective. Time seems to fly by when we're engaged in enjoyable activities, while it crawls at a snail's pace during moments of boredom or distress. This elasticity of time is a testament to the intricate workings of our brains. Our perception of time is also influenced by our memories and anticipation. We tend to overestimate the duration of past events that were emotionally charged, while future events often seem closer than they actually are. Section 8. Time travel. Fact or fiction? The concept of time travel has captivated our imaginations for generations. Could we one day build a machine that allows us to journey through time, visiting the past, or venturing into the future? While time travel remains firmly in the realm of science fiction, Einstein's theory of relativity does not explicitly rule it out. Some physicists believe that wormholes, hypothetical tunnels connecting different points in space-time, could potentially serve as shortcuts for time travel. Section 9. The arrow of time. A one-way street? One of the most perplexing aspects of time is its apparent directionality. We experience time as flowing from the past to the future, never the other way around. This unidirectional flow is often referred to as the arrow of time. The arrow of time is intimately linked to the concept of entropy, a measure of disorder in a system. The second law of thermodynamics states that entropy always increases over time in a closed system. This relentless increase in disorder provides a directionality to time. Section 10. Time's enigma, unanswered questions, and future explorations. Despite centuries of scientific and philosophical inquiry, the nature of time remains one of the greatest mysteries of the universe. From the ancient sundials that marked the passage of days to the sophisticated atomic clocks that measure time with incredible precision, humanity has always been fascinated by the concept of time. We have made remarkable strides in understanding its physical properties and its relationship to space, gravity, and the quantum world. The theories of relativity and quantum mechanics have provided profound insights into how time behaves under different conditions. Yet, fundamental questions linger. Is time truly fundamental, or does it emerge from a deeper level of reality? Some theories suggest that time might be an emergent phenomenon, arising from the interactions of more basic elements of the universe. What is the nature of the present moment? Is it a fleeting point that moves from the past to the future, or is it something more complex and elusive? Can we reconcile our subjective experience of time with its objective properties? Our perception of time can vary greatly depending on our mental state, activities, and even our age. This subjective experience often seems at odds with the precise measurements provided by scientific instruments. These are questions that will continue to challenge and inspire physicists, philosophers, and curious minds for generations to come. The quest to understand time is not just a scientific endeavor, but also a deeply philosophical one, touching on the very nature of existence and reality. As we delve deeper into the cosmos and unravel its secrets, perhaps one day, we will finally unlock the enigma of time. The answers may lie in the vast expanses of space, in the tiniest particles, or in the intricate workings of the human mind. Until then, the mystery of time remains a profound and captivating puzzle,